I'm Paul. I'm one of the principal engineers on the Consul team. And I'm representing the whole Consul team here today to talk a bit about what we've been building for the last year or so. So last year at HashiCorp Global in the US, Preetha and Nina gave a Consul roadmap talk where they kind of told a story of a startup called StarNav who went right from like an MVP application through to being a large, complicated enterprise. And they talked through how Consul solved a lot of their networking problems and along that journey. And so I want to start today with kind of a lightning-fast recap of that story, because I think it sets the scene well for the things we want to talk about today. But this is going to be a really quick summary, so I encourage you, go and find this recording later if you want to hear a bit more about the detail of any of these first few bits. So StarNav started with this simple application, just had a kind of couple of different back-end services. And here Consul was just an easy solution that they could drop in and use DNS-based service discovery. But as they grew, they found that they needed hardware load balancing to kind of handle some of the more complicated situations, handle some of the traffic for their services. And here, Consul Terraform Sync was a solution that helped them to automate that hardware as services got deployed and as things came and went within their infrastructure. Soon, this company grew, and now it has several different kind of autonomous application teams who are choosing their own technologies and who are building their own applications. In this case, they chose to deploy their applications in Kubernetes. And now, StarNav kind of needed a central team who could standardize the way all of these teams were managing their networking. So they used Consul as a service mesh so that they could kind of have this standard way to secure and observe and kind of provide resilient networking for all these applications right across all of these teams. And here, having that one standard tool that all these teams could use was really important to kind of tame this exploding complexity within the organization of all these new technologies and new teams running things. Eventually, StarNav needed to expand into new regions. So Consul's WAN federation and Consul's mesh gateways allowed them to secure their traffic between their regions and enable that expansion. And finally, StarNav grew to be a kind of a larger, more complicated enterprise. Now this kind of central platform team is not just helping all the application teams, but it's become a bottleneck for deploying new services, and especially configuring how they're exposed to the public internet. And this is where Consul's mesh and Consul's API gateway kind of allowed that team to automate how services get deployed and delegate to application teams how they want to expose their services publicly. So this picture is where Preetha and Nina left this organization's evolution and their architecture last October. And even though I went through this really, really quickly, I hope it gives a bit of a flavor of the sorts of solutions that Consul can help you with. But I want to pick up on some of the underlying organizational themes we've heard here and that we heard in the keynote this morning, too. We've talked a bunch about this pattern of a platform team that needs to provide kind of a standard networking solution to this large organization of more or less independent application teams. Often, these different application teams have made their own choices about their cloud providers, their runtimes, the technology stack that they're using. But despite these kind of different diverging choices, the platform team's task is to provide common tooling, common deployment tooling, tooling around observability, and security, and managing how teams connect securely between each other. So to deliver all of that, this platform team really needs a standard networking tool or a standard networking layer that they can build all of their automation against, rather than having to try and support every possible different networking setup that different teams are using. And they need that one tool to run in all of the runtimes and environments that their application teams are choosing. It's no good standardizing on a tool if it doesn't actually work in the places that all of your teams need it to. So Consul aims to be that solution that works across all of these different runtimes and provides you that consistent layer of automation within your network. So you can kind of consistently secure, provide observability into, and manage all the service traffic in your organization. Last year in October, we hinted at a few coming soon features that were mentioned in the keynote this morning. And they're here now, so I want to talk a bit more about those in detail. The first one of those is admin partitions. So as Armand said this morning, you can think of admin partitions a bit like virtualization, but for Consul clusters. So with virtual machines, what you're doing is separating the concerns of operating the kind of physical hardware, racking the servers, plugging the network cables in, and managing power supplies and so on, from the concerns of being able to provision instances and being able to deploy applications onto that hardware. So in a similar way, admin partitions in Consul separate out those platform team concerns of actually operating Consul servers and infrastructure from the kind of application team concerns of needing to manage their mesh traffic and their routing and how things set up and deploying their applications in a progressive way. So let's unpack this a little bit more. This platform team needs to standardize how the service teams here can manage securely connecting their applications. But these service teams kind of independently manage or deploy into their own Kubernetes clusters. So Consul's WAN federation and mesh gateways that we heard about just now can technically solve this problem. But they're not ideal in this situation for a couple of different reasons. The first one of those is that WAN federation, if you know Consul, it requires that each cluster you want to federate together is a Consul data center. And that means that it runs its own stateful set of Consul servers. So this means that the platform team now has to operate at least 3 servers inside every single Kubernetes cluster that they want to support and connect together this way. Obviously, that increases operational burden for them. There's a resource cost, especially if those are very small Kubernetes clusters. But worst of all, it means that this central team has to coordinate with all of these application teams for access to their cluster and every time they need to roll out upgrades and so on. And it's not uncommon in our experience to hear of platform teams who have to support tens, maybe even hundreds of Kubernetes clusters within a particular region. The second issue is that Consul's WAN federation is designed for this kind of global cluster model. And so there are many things that are configured globally. Namespaces in each data center are considered to be the same thing. And only one of the data centers, the primary one, can manage global state, like ACLs, like service intentions, like a lot of the mesh configuration. And what that means is that application teams can't really configure their own mesh or within their own Kubernetes cluster without kind of stepping on each other's toes or without coordinating with other teams as well. We'll say a bit more about that later. So admin partitions were added in Consul 1.11, and we released that back in December. And they solved this set of problems directly. Now the platform team only has to operate a single set of Consul servers within each region, and they can create a separate admin partition for each of those Kubernetes clusters. Each partition has a completely independent catalog, KV store, distinct namespaces, independent mesh configuration, even a completely independent ACL system, and intentions, and so on. So now full control over the mesh, over the routing, over deployment, and so on can be delegated to each application team and can be completely independent in each of these Kubernetes clusters, even though they're sharing the same servers. Services in different admin partitions within the same region on the same console servers can use mesh gateways to connect between them, just like they could between data centers with WAN federation. So to use a different phrase, a different way of talking about this, admin partitions provide multi-tenancy in console clusters. But you may be wondering, if you know console well, don't namespaces already provide multi-tenancy in console clusters? Why do we need a different thing for this? And the answer is that, yes, they both provide multi-tenancy, but they provide different ways of managing tenants. And it's going to depend on how your organization operates infrastructure as to which one works well for you. So namespaces are great at carving up like great big shared compute clusters. So you can think of like the original Google Borg-style cluster management, where they had kind of warehouse-scale clusters that are managed by a central team. Application teams just kind of get tools to deploy into this thing, and they don't know where anything's going. They just kind of know what resources they need, and it gets scheduled for them. Namespaces work really well in this kind of situation, where you can just kind of carve out a set of permissions within this big cluster and only give one team permissions for that set of resources. In this model, it's all about sharing resources and kind of packing all those teams into one kind of centrally managed set of infrastructure. But this turns out not to be the emerging model that many other organizations, even though they're using Kubernetes, even though Kubernetes was inspired by this Google model of doing things with Borg, that's actually not how most organizations are using Kubernetes now. And what we see instead, and especially since kind of the easy availability of managed container orchestration on all the cloud providers. There is a managed Kubernetes service on every cloud provider. There's often another custom managed container service. What tends to happen now is that each business unit or each application team just go and provision their own Kubernetes cluster. And now when you want to standardize across your organization, it's about trying to figure out how you standardize across all these different Kubernetes clusters that are being operated by different teams. So why aren't namespaces enough for this kind of reality we see? Well, if we come back to this platform team slide, we can start to understand why. Notice how each of these application teams has chosen to name one of their namespaces admin, which makes sense. They weren't thinking about what any other team was doing at the time. But if we just join these two clusters into a single console data center, how do we manage permissions for that admin namespace? Which team gets access? Do they both get access? What if one team creates an intention for admin/star? Is that going to allow traffic that shouldn't be allowed in another team's workloads, and so on? Another common result is that because these teams went and provisioned their clusters kind of without coordinating with each other, they both picked the default for the CIDR range for their overlay network or their VPC. And so now when you want to try and connect services between these two teams, you can't just peer the networks their clusters are running on together easily, because they're using overlapping private network blocks. So with admin partitions, being able to not just have this kind of logical namespace thing, but being able to kind of model this as a higher level abstraction lets us be more flexible with how we route things. It lets us assume, or rather not assume, that the networking is still flat in between them, and allow routing between partitions to occur over mesh gateways, which means that the private networks never have to be linked. Only the mesh gateways need to be able to contact each other. So admin partitions let your platform team operate shared servers to support multiple application teams and their clusters. But there was a limitation that I mentioned in that. And that's that admin partitions in console 1.11 could only connect partitions on the same servers. And that really meant just within a single region. The good news is that this morning we announced cluster peering will be available in console 1.13. And that will extend this federation support. So I want to talk a bit more about cluster peering. Cluster peering is not just kind of an incremental enhancement to admin partitions. It turns out that we kind of needed to go back and rethink how console clusters federate from the ground up to really make this model work. And I want to spend a few minutes kind of explaining why that is. So when Consul was first designed, infrastructure tended to be deployed in kind of on-prem data centers or even just cloud regions that were just treated like big data centers with a flat network. And generally, WAN Federation, it's called, it's Wide Area Network Federation. It was designed for federating between these different regions. So service discovery with WAN Federation works by forwarding those service discovery requests from the servers in the region that's making the request to the servers in the region that is the source of truth for what services are in that region. And so just to get basic service connectivity between your Consul clusters, you have to federate them all together so that they know where to forward all these requests. So Consul's federation design assumed that there's this single global operator or a team of operators who manage all of the Consul servers across the whole organization's infrastructure. And that generally was the case when, nearly 10 years ago when this was being built. And we see that property, or that kind of underlying assumption, play out in a few of the properties of WAN Federation. First of all, federated Consul clusters share their security keys. If you're allowed to operate one of the clusters in the federation, you're allowed to operate all of the clusters. And in fact, you kind of have to operate all of the clusters, because we assume that if you're upgrading Consul versions, if you're rolling out new security keys and so on, that you're going to coordinate that across all of the clusters. There's like a protocol for making sure you do the secondaries first and then the primary and vice versa in different situations. And finally, because we have that global permission state, because operators are permissioned the same way in all the clusters, we have to have this idea of a primary data center to be the source of truth for all that global state. If all this matches the way that your infrastructure operates and the way your teams work with your infrastructure, then it's generally pretty good. WAN Federation offers a relatively simple solution. You just have to configure the servers to know about the IP addresses of servers in your other data centers. And that's pretty much it. You can now connect any service to any service across all of your infrastructure. It's worked really well for a lot of organizations for years. But as we've been talking about, we see some changes in the way a lot of organizations are deploying that infrastructure. And they don't fit so well with this model. We already saw this kind of conflict arising where these two independent teams manage their own Kubernetes clusters. There's no global infrastructure operator here anymore. Even if you do have this central platform team that want to own Consul, they don't necessarily have access to the networks or the clusters that they have to deploy and manage Consul into. We also have a lot of users who run some Consul clusters themselves, either in the cloud or on-prem, but they also want to start consuming HCP Consul for some of their newer cloud workloads. But again, this crosses an organizational boundary. Like HashiCorp operates HCP Consul clusters, and the customer operates their clusters, and so we've kind of broken that underlying assumption that there's only one operator and one set of security keys needed. And having those clusters be dependent on a single static primary causes a lot of problems, and not least if that primary cluster is operated by a different team to yours, right? It makes disaster recovery planning between your teams extremely difficult, and it adds a lot of friction for how do you manage that global state and like ACL policies and so on. So to solve all of this, we kind of had to rethink how Consul federates between clusters rather than just kind of building on top of what we had. So we need a way to enable service connectivity between different clusters, but without assuming anything about who's operating those clusters or where they're running in the network. And that's exactly what we've done with cluster peering. So with cluster peering, WAN federation is no longer needed in Consul. Each of your clusters becomes entirely independent. It has its own keys, TLS certificates, catalog, its ACL systems independent. It can be just operated as if it's just a single standalone Consul cluster. There are no more primary clusters. Cluster administrators who need to connect to a service in a different cluster explicitly establish a peering with that cluster. So they exchange a token with the operator of that other cluster, and they kind of mutually configure trust between these two clusters. And then these two peers automatically exchange the relevant information from their catalogs, just so that we can enable the routing and the security and so on between these two services on either side. Importantly, we only export data about services which have been explicitly exported to a peer. So unlike WAN federation, where as soon as you're federated, everything can connect to everything, with cluster peering, you get to say, I want to peer with that cluster, but only these 3 services need to be contacted by that cluster. So with this new kind of loosely coupled federation model, we can now enable secure connectivity between any set of clusters, whoever owns them, wherever they're running in the network. And also in Consul Enterprise, cluster peering works just the same way for admin partitions. So now each partition owner or team can choose how they connect to any other team or any other region kind of independently, even when they're sharing the same set of console servers. So let's recap quickly the difference between these two federation models. WAN federation is kind of this global infrastructure. One team manages the infrastructure level, and you're just controlling access to higher level resources. But cluster peering gives you this kind of fine-grained control. Now, each cluster can be independent, and you can control exactly what connects between each other. With that increase in flexibility, though, comes the potential for a lot more configuration. Right? If you need to configure lots of different services talking across lots of different clusters. And that's something that we're very aware of and have some plans to streamline that I'll touch on in a second. So as we announced this morning, Consul 1.13 will include this new cluster peering feature. There's a tech preview available on our website today. So if you're interested in this, please download it and try it out and give us some feedback. And this will be available towards the end of July. But this really is just the first phase of this new federation model that I've been talking about here. Cluster peering is kind of like the new building block. It's the new foundation for a different way of working with multiple console clusters. And we have plans to build on this, both with automation for workflows where you do have like a whole set of data centers that need to be federated together, and whole new workflows for how you manage multiple clusters in a much more flexible way. But this is just a teaser slide. All of these things we'll be going into more detail on later this year. In the long term, we see this new federation model growing to replace WAN federation in Consul. But it's going to take us a while before we get to kind of parity with the workflows and the ease of use for certain work cases. So you don't need to worry about like upgrading and migrating to cluster peering right away with this release. But over the next few releases, we'll kind of talk more about how you can start to take more advantage of this if you have existing federated production clusters. So if you want more info on any of this stuff, including kind of a demo and a walkthrough of actually how this works in practice, Blake, sadly, Hannah couldn't make it to be with us, but Blake is going to walk through this right here on this stage at 3:45 today. This should be a great session, so do come along and check that out. So this new federation model has been a really big change in Consul, and it's an important change for how we will build things in the future. So I've spent a lot of time focused on that today. But I want to spend just a few minutes kind of highlighting some of the other things from the last year or so. We heard a lot about this in the keynote this morning, but the Consul and Vault story has come a long way in the last year. In Consul 1.11 in December and in 1.12 earlier this year, we released kind of a range of different enhancements. And a lot of those also, when you're using Consul and Kubernetes, you can now use Vault to manage all of your Consul secrets. You don't need to use Kubernetes secrets for that at all. And a wide range of other things. If you're using Kubernetes and Vault and Consul together, you now don't ever have to worry about rotating your Consul server TLS certificates, because that will all happen automatically for you. So some great updates there. I see one person's excited about that. Thank you. We also talked a bit about API Gateway last year, and as Armand said, we released that this year with a GA in February. And this is based on the Kubernetes Gateway API spec. This is a new spec that we've been collaborating with the networking SIG and the Kubernetes community over the last year or so. But this is just the first phase of our API Gateway plans. And later this year, we expect to expand this support to non-Kubernetes environments too. So both the Consul and Vault integration and the API Gateway are going to be explored in a lab session, which is being broadcast on our virtual event that's going on right now as well. All of you will have access to that. If you've not already logged in and registered on the website, you'll need to do that. But you can do that. And so at 12 p.m. today, there'll be a live session going through a hands-on lab for all of these features from the wonderful Daniela and Eddie from our own education team. So please check that out. And there's also a session later from Rosemary, our wonderful developer advocate, and she'll be covering a lot of things, Consul and Vault together, including Vault to manage CA certificates for Consul Mesh and for API Gateway. And that'll be right in here at 2:45. Last year, we also announced official support for Consul on Amazon's Elastic Container Service. And we've since shipped a GA version of that in November, and two other releases. 0.4 adds full support for Consul Enterprise namespaces and admin partitions as well. And finally, our managed Consul service on the HashiCorp Cloud Platform has been available on AWS since last year. But today we announced that it's now available in Microsoft Azure as well, and will be generally available next month. So this is kind of the tip of the iceberg in terms of all of the enhancements and features we've added over the last year. But just from seeing these kind of big items, I think they continue to tell that same story that we started with, of Consul being this standardized networking tool that runs everywhere your applications do. And if you want to see what a multi-platform service mesh looks like in practice and what it takes, please don't miss the session later, presented by my good friends Luke and Eric, who are right here. They're from Consul's engineering team. And they will cover running a mesh across Kubernetes, Nomad, ECS, Lambda, and regular VMs. And not just in theory either. I hear they have an audacious live demo across 4 different runtimes, across 3 different cloud providers. So let's hope the Wi-Fi holds up. But yeah, come back and see that at 1 p.m. just right here. I want to end with just the tiniest glimpse of what to expect over the next year from Consul. We've already mentioned some of the plans around improving our multi-cluster management story on top of this new federation model. And of course, we're going to be building support for additional application runtimes. We're also really excited about some architectural changes to Consul that we've been working on for the last year or so. They're going to really simplify operating Consul clusters even further for all of us. So with that, I want to just thank you for your time today, and please check out those other sessions, and come and find us over on the booth later if you've got any questions about that. Thank you so much.